Alright, hello everybody, this is Mr. Loken again. Congrats to you for making it to this video. Good work. And congrats to me for finally charging my iPad. If you look up there, it's at 100%. So all of you that have been super worried about my iPad dying, there you go. I charged it this time. So, we're starting with vocab, but we won't go up for vocab. All the vocab words that we have this lesson are in the lesson notes, and you actually have all the definitions already. So you can go ahead and copy these into your vocab section, because all the vocab words are already written out for you. All right, so this is 1.5. This is all about angles, and we're actually covering a lot of information today. So we're going over a lot of different types of angles and what we can learn from angles. All right, so first thing we're talking about is what's called adjacent angles. The word adjacent means next to, so just think of adjacent angles that are angles next to each other. But more specifically, we could look at it is when two angles that lie in the same plane have a common vertex. So that's one thing. That's one thing to look at. Common side and no common interior points. So we have to have all three of those in order for it to be an adjacent angle. So these two kind of figures on the left are both examples of adjacent angles. If we look at this and this, both of them, they fit all three. They have a common vertex. Remember, a vertex is the point that the angle is kind of created from. So both of these angles have the same vertex. They also have a common side. They both share that line there. And then they don't have any common interior points. Interior points is if we looked at this angle right here. An interior point means a point that's on the inside of the angle. So that could be an interior point. All of these could be interior points. They're points that are scattered throughout that angle. And then this would be another example of adjacent angles. They share a common vertex. They share a common side. And they don't share any interior points. So those would be examples of adjacent angles. The figures on the right would be examples of not adjacent angles. And what this figure on the left is referring to is this angle here and this angle. The picture doesn't show what it's referring to, but that's what it's referring to. So if we looked at both of those angles, this one and this full one, they share the same vertex right here. And they actually share the same side, but they also share common points, common interior points. That point right there is an interior point for this angle, but also this angle. So that's an example of not adjacent angles. And then this one, if we looked at this angle here and this angle here, they share a common side, but not the same vertex. So that would be an example of not an adjacent angle. Alright, moving on. Vertical angles is when two non-adjacent angles formed by two intersecting lines. So when you have two lines that intersect, vertical lines are just kind of opposite angles. So those two would be vertical angles. And then this and this would also be vertical angles. Alright. And the other thing to know about vertical angles is vertical angles are always the same. Alright, so these two angles are congruent to each other, and then these two angles are congruent to each other. So vertical angles always are formed by two intersecting lines, and they're always the same. This would be an example of not a vertical angle, because this is a straight line, but this is not a line, obviously. Alright, so these two angles would not be vertical angles. Alright. Next, a linear pair. A linear pair is actually just angles that are formed by two opposite rays. Alright, so if we looked at this example here, this is a ray, and this is also a ray. They're opposite rays. Angles formed by that, we call that a linear pair. These are rays right here, but they don't form like a straight line. So that's an example of not a linear pair. In order for it to be a linear pair, it has to form a straight line. Alright? Next, we have a word problem, not a word problem, but an actual example here now. So it says find the missing measures, then name an angle pair that satisfies the condition. So we have this figure. We'll get a lot of these questions where you kind of have to figure out the missing angles. It's a common one in this first chapter of geometry, and actually the rest of, especially this first trimester of geometry, where you got to find the missing angle and missing side. So we got to use the information that we do know. If you look at this figure, we need to figure out what this angle is and this angle is. And we actually have all the information we need. We will go over this. Let's see. Actually, let's cover this page first, and then we'll go back to that other problem. Vertical angles, we already talked about that and how they're congruent. Remember, they're vertical angles, they're the same. Complementary angles, you should know that, but it just is two angles that measure up to 90 degrees. So two angles that form a 90-degree angle. Supplementary is just the same thing. Two angles, the same but different. Two angles that measure, that measure up to 180 degrees. Alright, so complementary 90 degrees, supplementary 180 degrees. Alright, and then we'll go back to that example here. So, if we look at a straight line here, this forms a straight line obviously right there. That means that this angle and this angle and this angle added up together would all equal 180. Alright, because all straight lines or linear pairs all add up to 180 degrees. So this angle plus this would give us 180. So we can make an equation: 52 plus x, which say x, plus 65 equals 180. If you did your algebra, you would figure out that that angle is 63 degrees. Alright, we could actually do the same thing for this angle as well, the other missing one. If we know this is 63, we could go 63 plus 52 plus y equals 180. And if you did your math, did your algebra, we'd figure out that that missing angle is 65. That's that measure and that measurement there. Alright, and then part A says find two obtuse vertical angles. Remember, vertical angles are angles that are, think, opposite of each other, formed by when two lines intersect. Vertical angles are just opposite. Alright, so if you look, the only obtuse angle that we have is this angle. So we gotta find an angle that's vertical to that. So if you look, there's a line here and a line here. Alright, and that forms this angle right there. So that would be an example of a vertical angle. So we could go the angle YZW. Alright, that's the vertical angle to that 115 degree angle right there. Next, two acute adjacent angles. Remember, adjacent means next to. Remember, it has satisfy those three conditions. Oh wait, I didn't fully answer that last question. YZW and VZX, my bad. There you go. Alright, and the next one, two acute adjacent angles. So acute, remember that means less than 90 degrees. Adjacent, meaning next to. So we could go, there's actually a couple examples. I'm just going to go with YZT if we look at this angle. That's an acute one. So we could go YZT, and then this one is next to, it's adjacent, shares a vertex, shares a common side, no common interior points, and that angle is also acute. So that could be the angle we're looking for. So angle YZT and angle TZW. Alright, so there's that. We will move on. We already did that page. This is kind of a tough one, but you will have a couple of these in your homework, so this is good that we're going over this. This is actually going back to algebra when you learned how to write equations and solve after writing equations. Remember, we called that writing the system of equations. Alright, so that's what we're going to do. We're going to make a system of equations. So it says find the measures of two complementary angles. Remember, that just means angles that add up to 90. If the difference, or difference means subtraction, if the difference in the measures of the two angles is 12. Alright, so I'm going to make a system here. So first, I could use this information in the first part. I'm going to have one angle be x and one angle be y. So x plus y equals 90. That's what it tells us. It tells us that by telling us that it's complementary. So both those angles added up together equals 90. And then it says the difference of the two angles is 12. So I could go x plus 12 equals y. X, the difference is 12. So if we added 12 to x, that would equal y. Alright, and then we have a system, and then we just got to solve. So, remember how to do this? If we look at this, we can do substitution. Since we know y is equal to x plus 12, we can plug that in for y. Alright, so we get x plus, and we sub in that for y to get our answer. Well, not our answer. Combined, we get 2x plus 12 equals 90. Subtract 12 from both sides. Oops, and you get 2x equals 78. Divide each side by 2. You get x equals 39. Alright, so that's one angle, 39 degrees. And we got to solve for the other one. Just plug that x back in. Plug 39 in for x into that first equation and solve for y. You would figure out it would be 51 degrees. Alright, so those two angles, 39 degrees and 51 degrees. There you go. And after you get the answer, it's a good idea to kind of go back into the original question and read it and see if it makes sense. That's a good suggestion for all of these. Go back and see if it makes sense. Alright, next. This is just talking about perpendicular lines. We don't really need to talk about this a whole lot. Perpendicular lines, just two lines that form right angles. The symbol is that little box. We talked about that last one as well. Alright, so that's perpendicular angles, just forms a right angle. Alright, next, angle relationships, where we are going to solve. Once again, like I said earlier, we have a lot of these problems. So it says find x and y so that AD and BE are perpendicular. Remember, we can determine lines are perpendicular if they form 90-degree angles. So, we have to solve this to prove that those two angles are 90 degrees. So, what we have to do, we could set this equal to 90. That's one way to do it. Actually, that's the way we are going to do it. So, if we want to prove that this is perpendicular, that this forms a 90-degree angle, I'm going to go 12y minus 10 equals 90. If I add 10 to both sides, I get 12y equals 100. Divide each side by 12, and we get y equals 8.3. Repeated. I'm just going to write 8.3. So that's y, and then if we wanted to prove that this angle there was 90, we could go 90 equals 6x plus 3x to give us 9x. Divide each side by 9, you just get x equals 10. Alright, so there's that. That proves that those angles are 90 degrees. Next, we are going to skip that because I'm running out of time. I'm only allowed 15 minutes, so I got 30 seconds more. Alright, so determine whether each statement can be assumed from the figure at the right. GHM and MHK are adjacent angles. MHK. We can assume that because they have a common vertex and share a side, no common interiors. Part B, complementary. I'm just going to give you the answers. No. And then the last one, yes. Alright, remember complementary adds up to 90. Alright, thanks, bye.